What is lens material properties? Corrective spherocylindrical lenses are commonly used to treat refractive errors such as myopia, hyperopia, presbyopia, and astigmatism. Both lenses and prisms are also frequently used to improve eye alignment and treat diplopia in strabismus. Eyeglasses also serve an important role in protecting the eyes from physical trauma and harmful radiation. Lenses can be produced using a variety of materials and designed with several optical profiles to optimize use in specific applications. Critical lens properties include refractive index, Abbe number, chromatic dispersion, specific gravity, and ultraviolet absorption. Lens material properties. Refraction is defined as the change in direction of a wave of light as it passes from one medium to another. The amount that the light changes direction depends on the indices of refraction of each medium and is described quantitatively by Snell's law. The index of refraction of a material describes how fast light travels through a material and is defined by the speed of light in a vacuum, 3 by 108 meters per second, divided by the speed of a given wavelength of light in the medium, equation 2. Snell's law relates the indices of refraction of two media to the directions of propagation in terms of the angles to the normal. Snell's law relates the indices of refraction of two media to the directions of propagation in terms of the angles to the normal. The index of refraction, n, defined as the speed of light in a vacuum, c, divided by the speed of light in the medium, v. The index of refraction is defined as the speed of light in a vacuum divided by the speed of light in the medium. A common misperception is that lens materials with a higher index of refraction have a higher physical density, mass over volume. In reality, it is not the physical density but rather the optical density of the material that determines the speed of a light wave through a medium. The optical density, or absorbance, of a material is a logarithmic ratio of light intensity entering versus exiting a particular material. The change in intensity is due to the tendency of atoms to dissipate some of the energy through vibration as light passes through it. Chromatic aberration results in a single beam of light to have a different focal point for each wavelength. Chromatic aberration results in a single beam of light to have a different focal point for each wavelength. Chromatic dispersion, also referred to as chromatic aberration, is a phenomenon where the speed and direction of light propagation in an optical medium depend on the wavelength of light. The interaction of the particular wavelength of light with electrons in the medium gives rise to this phenomenon. When a single beam composed of multiple wavelengths of light passes through a lens, each wavelength of light will change direction and speed to different extents. As a result, the index of refraction for a given medium will vary based on the wavelength of light going through it.